Okay, 2.6 transformation of functions. This is learning how to do all the transformations that you did in Algebra 2. So we're going to go over and review some of this stuff. It's pretty simple. I'll give you my take on how easy it is to do this. But this is, again, the baby steps of looking at a problem and knowing how to graph it, or knowing what it looks like, and picking up on some really important information from the equations before you actually use the technology that you have. So you should know what things look like and what is happening in a graph looking at an equation before you begin. So let's take a look at some basic stuff. So you should probably make sure you have earmarked that page 166, which is all the parent functions of the equations. So a parent function would be something like this, y equals absolute value of x. So we'll use this as an example to get started. So y equals the absolute value of x. What does that look like? Yeah, it looks like a v. So it's important that you understand where that is, okay? And almost everything is going to be at the origin. So if I were to draw y equals the absolute value of x, it would look like this, okay? And the slope of the line would be up 1 over 1 or down 1 over 1 if you're on the left side there. So here's how the parent functions work as you transform them. Everything on the inside is horizontal, so this is important. Inside is equal to horizontal movement, and outside is vertical, meaning up and down. Horizontal is left and right, vertical is up and down. For those of you who are still struggling with that, horizontal is left and right, and vertical is up and down. Okay? All right, so if I were to write this, y equals the absolute value of x, and say plus 1, that is inside the function. So something you need to remember about horizontal movement, it is opposite what you think it's going to do. So a plus 1 inside here, you would think it would move everything to your right. That's incorrect. It's going to move everything to the left if it's a plus, okay? So inside the function is always left or right, it's horizontal, and it's always opposite of what you think it's going to be. All right, so this would shift left 1 unit. Okay, let's keep going. So y equals the absolute value of x plus 1 minus 2. And these are the easy ones that we start out with Algebra 1 and Algebra 2. We see these things. And in Algebra 2, you probably did a lot of these same problems, but we'll take it a little step further. Not much. It's a fairly simple lesson for you. If you did well in this in Algebra 2, you should do well today, okay? So this is on the outside. The minus 2 is on the outside. So that means it's a vertical movement. So this would shift down 2 units. Okay? So if it's on the outside, it does exactly what you think it's going to do. All right? Okay, so now we're going to use that same thing, and we're going to keep adding to it, okay? So we had x plus 1 and a minus 2. Let's go ahead and say y equals 2x plus 1 minus 2. Yes.
Would it be a vertical stretch?
Okay, so that's a great question. So now the question that you have to ask yourself every time you're looking at a transformation is, where is this movement? So on the inside, you got a +1, shifting left 1. On the outside, you have a -2, is shifting down 2. But the 2 times x, the 2, the coefficient on the x, is inside the function. So it would be a horizontal shrink. It's opposite what you think. So this would be a horizontal shrink by a factor of 1/2. Huh?
Was it like the reciprocal?
It would be on the outside, would it be reciprocal?
So the next one is y equals 3 times absolute value of 2x plus 1 minus 2. So the 3 would be a vertical stretch by a factor of 3. Exactly what you think it is. If it's on the outside, it's a vertical movement, exactly what you think it's going to be. If it's on the inside, it's always going to be opposite. And if it's a stretch or shrink, it's going to be reciprocal. So if in the horizontal shrink here, if that were 1/3, you would say it's a horizontal stretch by a factor of 3. Okay? So it's always the reciprocal. You look at the reciprocal, and if it's bigger than 1, it's going to be a stretch. If it's less than 1, it's going to be a shrink. Okay? But if it's inside, it's opposite of that. All right? All right. I'm just going to put some examples on here, and we'll add another one. And let's see. Let's do example 1. Let's do, this is how it's going to look in the book. So I'll do this just to make sure we understand what it's saying. F of x plus 4. So when it's written like this, you're looking to see if it's inside the parentheses or if it's outside the parentheses. So is it inside or outside? Outside. So this means this is going to be a vertical shift or stretch or what? Shift up plus 4. Okay, so that's right. It's going to shift up 4. Example 2. I'll just give you another one here. 1/3 f of x. So write down what you think it's going to be. It would be a vertical shrink. So it is on the outside, so it's a vertical movement, and if it's vertical, it's exactly what you think it's going to be. Since it's less than 1, it's a shrink. So it's a vertical shrink by a factor of 1/3. Okay, so on the test, you're not going to be given a graphing calculator. You're going to be asked these types of questions. Okay, so when you're doing your homework tonight, you can use your graphing calculator. You can plug this stuff in to real equations here in a second. I'll show you, just to verify what it is you think it is. Remember, you need to be practicing for the test. All right, so let's do another example. Example 3. Oh, let's see here. Let's do 4 f of x plus 1 plus 3. So I'll give you everybody a minute here. I'll pause this. You write down what you think is happening. All right, so shift left 1, up 3, and a vertical stretch by a factor of 4. Now, let's look at a real problem here. Let's do x squared, this is f of x equals x squared minus 4. Everybody write down what you think it's going to do. Okay, everybody should have said this is a parabola that shifts down 4 units. Okay. So here's an example of what it would look like if you would have thought it was shifting left or right. Oops.
What the parent function is? Like I know that.
No, it's not asking that.
You have to ask
So like
that.
it does, on this one it does say sketch the graph and then explain it. So sketch the graph of the function, not by plotting points, but by starting with the graph of a standard function and applying the transformation. So in this case, you do need to know that it's a parabola, and this is your typical parabola, x squared. But this is going to shift it down 4 units. So you would just do a rough graph like this. Okay? So it shifted down 4 units. Here's what it looks like if you were to have it on the inside of the function. It would have looked like this. X minus 4 squared. And that one would have shifted to the right 4 units. 1, 2, 3, 4. And that would have looked like this. Okay? So that's the difference. All right, let me give you another one. Let's add another one. And what example is this? 5?
Yeah.
The y equals 3 minus 2 times x minus 1 squared. So I'm going to pause it. You guys write down what you think is going to happen. Okay, so the 3 out in front here really could be put over here if that makes you feel better. So if you want to rewrite it, you could write it like this. Y equals negative 2 times the quantity x minus 1 squared, and then a plus 3, if that makes you feel better. But you got to be confident in what it is. And if you're confident, you probably didn't need to move it to begin with. The point is it's on the outside. So it's just a number added to it. So it's going to shift up 3. Okay, so up 3. And it's going to have a vertical stretch, exactly what you think. It's a vertical stretch by a factor of 2. And what does the negative mean?
Oh, it flips or something?
Reflect what? Vertically. So if you're reflecting vertically, it's over the x-axis. So when you read that in the back of the book, it says reflected over the x-axis, you need to remember that if you're going over the x-axis, that's a vertical movement. Okay? So reflect over x-axis. And then on the inside here, right 1 unit.
Do you care if we say reflect or flip?
Nah, that's all right. Just say reflect. It's not that big a deal. Don't be lazy. All right, so let's do something else here. Okay. So as long as you know that that 3 is by itself, and that means it's going to be a vertical shift up.
How do you know it's by itself?
Well, there's nothing multiplied by it, and it's not inside the parentheses. The 2 is multiplied by that parentheses, right? There's nothing attached to the 3.
Okay.
That's how I know it's a shift up 3 units.
Well, I thought it was just like a 3 minus 2, which got you 1.
No. Oh no, you can't do 3. You can't do a minus before you do that multiplication. That's what I'm saying. Now that you understand, you probably don't need to move it. But there are a few people that'll look at that and say, like, okay, I'm supposed to move that. Don't know why, but I'm supposed to move it. All right, let's go back to 6. Here, I want you to do this. I'll write this down. F of x equals x squared. Shift 2 units to the left and reflect in the x-axis. Go ahead and write what that is going to look like. I'll pause it. Yeah, which question?
How do you know if it's over the X or the Y?
The reflection, you put a negative somewhere where your vertical or horizontal stretching or shrinking would be.
Oh.
All right, so I'll give you a minute. You have a question over example 5?
Yeah, I did 3.
6 here. All right, sounds like you're ready. All right, so let's write f of x equals, we're shifting 2 units to the left. So it's a horizontal movement, so that's going to be inside the function. So 2 units to the left means plus 2, thank you. And then reflect in the x-axis. So that's a vertical movement. So it's going that means your reflection means a negative. So where are you going to put that if it's a vertical thing? Outside. So it just goes right like that, and that would be the answer.
Could I do -1?
You can put a -1 there. You just don't need to. Okay. Good. Want one more? Or are you good?
Yeah, do another one.
All right, let's do another one. Example 7. Number 62 is f of x equals the absolute value of x. All right, so shrink vertically by a factor of 1/2. Shift to the left 1 unit. And shift up 3. All right, I'll pause it, give you a minute. Let's see how we did. So vertically, we're shrinking. So it's vertically, that means this number is on the outside exactly what it says, by a factor of 1/2. So we're going to put 1/2 here. All right, on the outside, so f of x equals. On the inside, shift to the left. Horizontal, that's on the inside. 1 unit, so left is what? Plus 1. And shift up, that's vertical, so that's on the outside. Plus 3. Who got that right? Yay. All right, I actually do want to do one more thing. Okay? So this... All right. So I'm going to give you a visual of a graph. I'm going to show you how it's going to ask you to graph the shrink or whatever stretch. I'm going to show you how to do it, so it's not...
How to draw it?
Yeah. So let's wait. You want to see that? Go to this example 8. This is going to be number 74A in your book, and just in case you want to look. Y equals f of 3x. So, and then here's the graph. So this will not be that accurate. It doesn't need to be. 1, 2, 3. And -1 here is... around right here, and at 1, 2, 3, and +1, we are almost to 2, but not quite. So here's what this looks like. All right, so there's a graph of a function. So what does the 3 do? Horizontal, shrink by a factor of,
Yeah, I think I'm a little mixed up there.
yeah, so anytime, oops, shrink. by a factor of 1/3. Here's what you do. You pick the points that you know. We do not know these two right here. I don't know where they're at, okay? But I do know this one right here at negative 3, 0. I know this one at 3, 0. So if it's a horizontal shrink, that means the vertical part isn't changing. That just means that this value up here is just going to shrink towards the origin. I don't know where that's at, but I'll show you here in just a second what you would roughly graph. Roughly means you're guessing. But I do know where these two are going to go. And 0 is just going to stay at 0. So what you do is you take all your x values, because it's a horizontal movement, you're not doing anything to your y's, you would multiply all your x values by 1/3. So what is 3 times 1/3? Right. 3 times 1/3 is 1. So that is going to be right here at 1, 0 now. So this shifted all the way to, not shifted, it shrank all the way to there. And negative 3 times 1/3 is what? Negative 1. So this shifts all the way to here. Now redraw the whole thing. Oops, I went the wrong way. Sorry. And that's what you would do. You would roughly draw, squeeze everything down into that position. I don't know where those peaks and valleys are. That's not what's important. It's important that you understand the shape has been scrunched down to that position. And again, we're trying to get you guys to the point where you know what's happening, you know what it's going to look like before you actually do use your technology to actually do it accurately. Okay? Because you need to know whether or not you mishit a button when you're plugging it into your computer or your iPad or your calculator. Right? Okay. So, yeah, I knew right away I was doing that wrong when I started drawing it. Okay, so that's it.